Hey everyone. Welcome back. Today, we're diving into a big question, one that's puzzled scientists, philosophers, and probably all of us at one point or another. Why do we age? What is it that makes our bodies gradually wear down over time? Why don't we just keep on going forever? Aging affects all living things, from the tiniest cells to the largest mammals. It's a natural part of life, but why does it happen? And why do we get wrinkles, gray hair, and face health challenges as we age? Let's explore the science behind aging, some of the fascinating theories, and whether there's anything we can do to slow down the process. Let's start with the basics. What exactly happens when we age? Aging begins at the cellular level. Our bodies are made up of trillions of cells, and each cell has a specific job. These cells continuously divide, repair, and replace themselves. But every time a cell divides, it loses a bit of its DNA. More specifically, the telomeres at the ends of our chromosomes shorten. Telomeres are like protective caps on the ends of DNA strands, and they keep our chromosomes from unraveling. Each time a cell divides, telomeres get shorter until they can't protect the DNA anymore. This is called the Hayflick limit, and it's essentially the cell's expiration date. Once telomeres get too short, cells stop dividing, which causes them to die or malfunction. When enough cells in our body stop functioning properly, we start to notice signs of aging, wrinkles, weaker muscles, slower healing, and so on. So, that's the basic cellular process, but why does it happen? Why do we have telomeres that shorten over time? There are several theories that try to answer this question. Let's take a look at a few of the most popular ones. Theory 1, wear and tear. First, there's the wear and tear theory. Think of the body like a car. The more you drive it, the more it wears down. Over time, our cells are exposed to all kinds of stress, pollution, UV rays from the sun, smoking, and even natural metabolic processes. These things create free radicals, which are molecules that damage cells. This wear and tear eventually takes a toll, making our bodies age. Theory 2, the genetic theory. Another theory is the genetic theory. This one suggests that aging is hardwired into our DNA, like an internal clock that tells our bodies when it's time to wind down. It's known as programmed aging. Some researchers believe that aging is actually an evolutionary adaptation. From a survival standpoint, it might make sense for older generations to pass away, making room for the younger ones. This helps prevent overpopulation and allows new generations to adapt to changes in the environment. Theory 3, mitochondrial theory. Then there's the mitochondrial theory of aging. Mitochondria are the powerhouses of our cells, responsible for producing energy. But as we age, mitochondria don't work as efficiently, and they start producing more free radicals. This damage accumulates over time, affecting the health of our cells and tissues. Theory 4, immunosenescence. Finally, there's immunosenescence, a fancy term for the aging of our immune system. As we get older, our immune system becomes less effective at fighting off infections and diseases. This leaves us more vulnerable to illnesses, which is why older adults are more likely to experience health issues. Okay, so we know that aging is a complex process. But here's the question everyone wants answered: can we slow it down? The good news is, there are things we can do to keep our bodies and cells healthier as we age. Scientists have found that exercise, a balanced diet rich in antioxidants, getting enough sleep, and reducing stress all have a positive impact on our cells and can help slow the aging process. In fact, research on telomeres suggests that healthy lifestyle choices can slow down telomere shortening. For example, certain diets, like the Mediterranean diet, have been linked to longer telomeres, which could mean slower aging. But scientists aren't stopping there. The field of anti-aging research is rapidly advancing, with some truly groundbreaking studies in the works. For example, There's exciting work being done with senolytics. These are drugs that target and remove senescent cells, or cells that have stopped dividing but haven't died. These cells cause inflammation and contribute to aging. By clearing them out, researchers believe they might be able to slow down or even reverse some aspects of aging. There's also gene editing, specifically through tools like CRISPR, which scientists are exploring to potentially repair or replace damaged DNA. And then, of course, there's NAD+ therapy. NAD+ is a molecule that helps mitochondria function and repair DNA. It naturally declines with age, but some studies show that boosting NAD+ levels might improve cellular health and extend lifespan. So, to answer the big question, why do we age? It's a mix of genetics, environmental factors, and the way our bodies naturally wear down over time. Aging is complex, but understanding the mechanisms behind it helps us not only embrace it but also find ways to potentially slow it down and improve quality of life. While we might not be able to live forever, the advances in science and technology mean that we could live longer, healthier lives than ever before. And who knows? Maybe one day, scientists will find a way to significantly delay aging. Thanks for watching. If you enjoyed this video and want to learn more about fascinating science topics, don't forget to like, subscribe, and hit the bell icon for notifications. See you in the next video. Until then, keep exploring, stay curious, and take good care of those cells.